Hello, welcome to the Mark Janard Show, the cybersecurity show. So Linux has a new feature called mseal, which makes it impossible for hackers to hack. In this video, I'm going to go over what it is and how it works so that you are aware of what it is. So without further ado, let's get right into it. We're going dark. So the new Linux feature that is being touted as making hacking impossible is called mseal, a new system call introduced in the Linux kernel. While the claim of making hacking impossible is an exaggeration, mseal does provide significant improvements in security against certain types of attacks. Now, here is how mseal works. mseal is designed to protect against memory corruption vulnerabilities, which have been responsible for approximately 70% of hacks in the last 20 years, right? The mseal system call allows the kernel to protect a page of memory, making it much more difficult for hackers to exploit memory-related vulnerabilities. Now, please take a moment right now to hit that subscribe button and like button if you're enjoying this content. If you really like it, if you want more content like this, please hit that subscribe button and the like button. Thank you. So the key aspects of mseal is it prevents changes to memory page permissions once sealed. Sealed memory pages cannot be unmapped, moved, or expanded. It aims to mitigate attacks that rely on modifying memory permissions, such as return-oriented programming, ROP attacks. Now, there is some context and controversy, right? The introduction of mseal in the Linux kernel has generated significant discussion and debate within the Linux community. Now, here is the main points of this whole hoopla, right? Now, the feature has been met with some controversy, particularly from prominent figures like Linus Torvalds. There are concerns about its implementation and potential impact on existing system functionalities. Now, there's a debate between complexity and versus security. The community is grappling with the balance between enhancing security and increasing system complexity. Some developers worry that additional security measures like mseal could complicate kernel maintenance and troubleshooting. There's also performance concerns. There are discussions about potential performance impacts, which is a critical consideration for servers and high-performance computing systems. Then there's compatibility issues, right? Some developers have raised concerns or raised questions and concerns about how mseal will work with existing applications and libraries, particularly glibc, right? And the design critiques. There have been debates about specific design choices, such as the inclusion of the map_sealable flag. Some argue this is unnecessary and complicates the implementation. And then there's the ongoing refinement, right? The feature has gone through multiple iterations based on community feedback. For example, version 8 of the patch set incorporated suggestions from various developers and addressed some concerns raised in earlier discussions. You have recognition of potential benefits. Despite the controversies, there is acknowledgement of mseal's potential to enhance security against memory corruption attacks, which have been a significant source of vulnerabilities. Now, there's different perspectives, right? There's all kinds of programmers, and programmers have different opinions and all kinds of stuff, coding, you name it, right? So the differing opinions or perspectives, the discussion highlights differences between the needs of specific projects like Chrome and the broader Linux ecosystem. There's also comparisons to other systems, right? Some discussions have involved comparing mseal to similar features in other operating systems, such as OpenBSD's Mutable, right? Mutable. Now, the gradual acceptance is, despite initial resistance, the feature has progressed through the development process and was eventually merged into the Linux 6.10 kernel, indicating a level of acceptance from the community overall. The reaction to mseal reflects the Linux community's commitment to rigorous debate and careful consideration of new features, especially those impacting core system security and performance. Now, there are some limitations and considerations, right? While mseal is a significant step forward in Linux security, it's important to note that it doesn't make hacking impossible, but rather makes certain types of attacks much more difficult, right? The effectiveness of mseal depends on its proper implementation and use by developers. Other types of vulnerabilities and attack vectors still exist and need to be addressed through various security measures. Okay, so it's very important for us to really understand the importance of open source security. The recent discovery of a backdoor in the xzutils, a widely used Linux utility, highlights the ongoing importance of vigilance in open source projects. This incident demonstrates that while new security features like mseal are valuable, the open source nature of Linux also allows for community-driven security improvements and vulnerability detection. So in conclusion of this part, while mseal is a promising new feature that enhances Linux security, it's an overstatement to claim it basically makes hacking impossible. It represents an important step in the ongoing effort to improve cybersecurity in Linux systems. So we talked about it a little bit, but let's get a little bit more into it, right? How does mseal compare to other security measures in Linux? So mseal is a new security feature in the Linux kernel that provides enhanced memory protection. Now, the way it compares to other measures in Linux is the comparison with existing features like the mseal versus mprotect. So mseal prevents changes to memory permissions and layout over sealing. Mprotect rather allows changing memory permissions but doesn't prevent remapping. mseal offers stronger protection against attacks that rely on modifying memory permissions or layout. Okay, mseal, now you have the mseal versus sel Linux, right? Or SE Linux / App Armor. So mseal focused specifically on memory protection at the process level. SE Linux / App Armor provides broader system-wide access controls and policies. mseal complements these mandatory access control systems by adding an extra layer of memory-specific protection. Now, mseal versus sec comp, okay? mseal prevents specific memory operations after sealing. Now, sec comp restricts which system calls a process can make. So while sec comp can block certain memory-related syscalls, mseal provides more granular control over memory regions. That's something that you got to keep in mind. So the key advantages of mseal is the targeted protection. It focuses specifically on preventing memory corruption attacks. Again, 70% in the last 20 years. There's the immutability. Once memory is sealed, it cannot be unmapped, moved, expanded, or have its permissions altered. That is another key. Then there's the mitigation of specific attacks, right? It basically helps prevent tampering with memory permissions, hole punching attacks through arbitrary unmapping / remapping. There's the integration with existing systems. Plans are in place to integrate mseal into glibc, potentially in version 2.41, expanding its use beyond browsers. And now, there are some limitations and considerations, right? The compatibility. It may impact some existing system functionalities, leading to debates in the Linux community about balancing security and system optimization. Now, the performance, like many security features, mseal may have some impact on system performance, especially for high performance computing scenarios. The scope, while powerful, mseal is not a complete solution for all memory-related vulnerabilities. It's part of a broader security strategy, right? Now, the system requirements, as of right now, currently, mseal is only available on 64-bit systems. So the conclusion to this, rather, right, mseal represents a significant advancement in Linux kernel security, particularly in addressing memory corruption vulnerabilities. It provides a more robust and targeted approach to memory protection compared to some existing measures. However, it's important to view mseal as part of a comprehensive security strategy rather than a standalone solution. Its effectiveness and adoption will likely evolve as it becomes more widely implemented and tested in various environments. So with all this talk about security and this and Linux and everything, do you think, there are some top Linux, secure distributions, right? You have the QUBES OS, and that is basically widely regarded as one of the most secure Linux distributions. The key security feature is the security by isolation approach using containers called QBES. Compartmentalization of different tasks and hardware into isolated areas, and it's basically endorsed by security experts like the late Edward Snowden. Tails is another one, which is the amnesic incognito live system, which is focused on privacy and anonymity, right? The key features are it routes all connections through Tor, the Tor network. It leaves no trace on the computer after shutdown. Lastly, we have the Linux Kodachi, and Linux, Kodachi is designed for privacy and anonymity. The notable features is all internet connections pass through VPN, then the Tor network. It includes advanced privacy and encryption tools. It can be run from USB drive or DVD. That's what I have for today. Please take a moment right now to hit that subscribe button and the like button if you enjoyed this content. If you loved it, if you're excited, please hit that subscribe button and the like button. Please let me know your opinions in the comment section below. I appreciate your viewership. Stay safe. See you on the next video.